The following has been developed by state and provincial educational agencies in association with the Agency for Instructional Technology. Together, programming for today's learner.
Dear Keisha and Claude, how'd you sleep in your new rooms? Mom and I had to get to work early and didn't want to wake you after how late you worked last night helping to unpack. Cereal's on the table. The box by the sink has all the dishes you should need. If you don't mind doing a few more things to help us get moved into the house, ha ha. I've prepared these envelopes for you to open one at a time. It could be fun. You'll be in danger of learning something. Hey, Claude! Claude!
What?
Come out here.
Keisha, it's only 10:30.
You won't believe what Dad left for us. The first thing I want you to do is to move the big black chair from the living room into Claude's room. I know it'll fit because the door is the same size as the one at our old place. Don't be afraid to take a guess on how to make it fit. The best way to solve some kinds of problems is by taking your best guess, then check and revise.
Take a guess. Easy for him to say. He's not breaking his back lugging this monster.
Did you hear anything break?
I don't think so. Pots, books, pans.
He's out of the way.
Yeah. He'll never fit.
Dad says it will.
You notice he's not doing it?
Well, let's try anyway.
Fine. Any more bright ideas?
Well, the chair isn't as deep as it is wide. Let's try it sideways.
Okay.
Fit.
You got any more brilliant guesses, Einstein?
If we turn it like this, it'll just make it wider, won't it?
Yeah, and any way we turn it, it's too wide.
Maybe Dad was wrong about the door.
I think half of us knew that already. Let me get something to eat. Wait a sec. What if we laid it on its side?
What?
Okay, we already know there's no way it'll go through standing up, right?
Yeah.
So why don't we lay it on its side?
Are you kidding? Look how high the back is.
Yeah, but look how low it is here. Maybe we can kind of spin it through the door.
Yeah, maybe.
Okay, ready?
Yeah. That was even worse. Dad's got to be wrong.
What if we put the bottom through first?
The only difference will be the bottom instead of the top will run into the door. This still isn't going to make it.
Run into the door. Hey, we're turning it that way.
Yeah.
What if we turned it that way?
Yeah, I think so. Should be.
Yeah. All right.
With math problems, guessing's gotten a bad name.
One kind of guessing deserves it.
Right. The kind when you turn off your brain and take one wild guess after another.
But guessing, or let's call it exploring for an answer, is something we do all the time without really thinking about it.
Picture this division problem. Divide 271 by 17.
Let's see. 17 goes into 27 one time. Subtract 17 from 27. Bring down the 1. 17 goes into 101. Let's see, maybe 6 times?
That 6 was a guess. It was a good guess, too. And now he's checking.
Whoops.
And now he's revising. Taking your best guess, checking, and revising can help in solving all kinds of problems.
One really good situation is when a problem totally stumps you. Guessing can help you to get started.
It's better to take your best guess and see where it leads than to just give up.
say?
Thanks for moving the chair. Good exercise, huh?
Ha ha ha. What does he take us for granted?
Next, would you please use these cables to hook the television to the videotape machine?
Is she kidding?
If you can get it to work, we'll rent a tape tonight and you two can pick it.
What does he think we are, electronics experts?
As long as you don't take the backs off the machines and make sure you just connect the right kinds of plugs, you can leave the machines on and there won't be any danger from electricity.
Yeah, I remember watching him connect it when we first got it.
I'm sure all the parts are here because I packed them myself. Remember, don't be afraid to start by taking your best guess.
Okay, he says don't worry about the UHF antenna for now. That's the one with the two little forks?
This must be it.
Okay, yeah. He says you can get the tape machine and the main channels without it.
Okay, so that leaves these two cables and this whatchamacallit. Turn it down!
You got any ideas?
Well, like Dad said, we have to make sure the plugs go into the right sockets. That'll tell us a lot anyway, right?
Hey, you got the TV. What'd you do?
I just connected the antenna to the TV.
Great. Now all we need to do is get the VCR going.
Yeah, now let's just connect these.
All right, I'll start this Oh We Are the World tape. So it'll go on when we make the right connections.
Hey, this wasn't so hard after all. There's only one place we can plug this. Is it working?
No. Wait. Why don't we hook up this cable? I mean, it's just like the one you did. Oh. Except there are no more sockets like those. Except these two.
Somehow, I don't think it's going to help to plug one end of that cable into the other.
I don't know.
Dad says he's sure we've got everything we need.
Notice once again that he's not here.
Okay, what do we know?
Well, my hunch is we should be using all these parts, don't you think? I mean, Dad took them off.
Unless that's a spare cable.
Well, if this were a spare cable, wouldn't that be working?
I guess so. Hey, you know what else?
What?
Shouldn't something be connecting the VCR to the TV?
Huh?
I mean, the tape in here is supposed to make a picture up there, right?
Yeah. And one of these cables should be running from here to there. Well, this is the only plug for it to connect to. Wait a minute. Where there's one plug, there's two.
I think we're getting more. Nothing.
Wait a minute. Let's connect the other one. Oh, no.
Wait.
Now we're cooking. I don't believe it.
What if something got busted when we moved?
We've tried everything.
Hey, wait. Maybe there's one more little change we could try.
What?
What if we switched them?
All right.
When you take a guess, it's important to think first and make it a good one.
Start by asking yourself, what do I know about the problem?
And learn from your guesses.
Keep on your toes.
Be systematic.
Make sure your guesses lead you somewhere.
Do you want to try a problem?
Me?
I want you to move one of the numbers on top of each of the circles.
Uh-huh.
So that every one of the outside rows add up to 9.
Each row of 3 numbers has to add up to 9.
Yeah, like 1 plus 2 equals 3. So for these 3 numbers to add up to 9, this would have to be 6.
This could take a long time to figure out.
Take a guess, but don't let me influence you.
That's okay. Why waste a good beginning? Let's see. How about this?
1 plus 2 plus 6, that equals 9, but 1 plus 4 is 5 plus 5, 10. That's a little high. 5 plus 3 is 8, plus 6, 14. That's way too high.
I told you it'd take time. I can't do it while people are watching.
Well, was there any pattern in your totals?
Let's see. Well, one way it came out a little too high, and another way a lot too high. I guess I have to watch out for high numbers. You can shoot past 9 really easily.
Okay, then why don't you use that idea to revise your guess?
Let's see. Corner numbers get added up twice. So let's keep them low. What if I put 1 here and 2 here? So for this row to add up to 9, this has to be 6.
Great. Same numbers as before, but a different order.
Yeah, I don't have 6 in this corner here. But what if I put the next lowest number on this last corner?
Looks good.
So, 1 plus 3 equals 4. This could be 5. 2 plus 3 equals 4. Hey, holy cow, it works!
Great job of guessing, then checking, learning from your guess and revising.
Thanks a lot.
We're at the Jet Propulsion Laboratory in Pasadena, California.
And this is Miss Donna Wolf, a mission planner who worked on the Voyager mission to the outer planets.
And this is a replica of the Voyager spacecraft.
Donna, could you tell us something about the Voyager mission?
The 2 Voyager spacecraft were the second mission to visit Jupiter and Saturn, and the first to visit Uranus and Neptune. Scientists often have to revise their theories based on information they get back from spacecraft. Your hypotheses at the start, before you start a mission, help you plan the mission in that you already have an idea of what is out there, but you want to see whether that's true or not. And so what you do is you put instruments on the spacecraft, and then once you get the data back, you check it to see whether it agreed with what you had thought. At Jupiter, probably there were 2 things that were the most surprising. One had to do with the satellite Io. Before we got to Jupiter, some people had said that there would be volcanoes, and some people had said that there wouldn't be. Well, we were actually able to take some movies of volcanoes going off on Io. Then we discovered a ring around Jupiter, which was not known before. At Saturn, we discovered that the ring system was actually much more complicated than we had thought before. Some people thought it might just be disks of material, and it turned out to be composed of lots of little particles. The satellite Titan at Saturn turned out to be very interesting because it was the first satellite that we studied that had an atmosphere. We would normally expect most moons to be like our own moon that doesn't have an atmosphere. At Uranus, we expected it to have a magnetic field like all the other planets. Normally, the magnetic field is somewhat close to the rotational axis, but at Uranus, it was 60 degrees different. And so that was one of the reasons why the scientists, as they were coming into the planet, had not picked it up at first, because they had expected something different. You can change where the spacecraft is going by firing the little jets, doing what's called a maneuver, and that'll change where the spacecraft is going. You can change the observing sequence by changing a computer program on board the spacecraft. Everything the spacecraft does is controlled by a computer. To be a good planner, you have to have knowledge of what it is you're planning. Then you have to translate that into, for example, a set of instruments. You have a large group of scientists you have to work with, and usually one group wants to do one thing and another group wants to do another thing, and so you have to coordinate the 2 groups. Also, you have to be open to being wrong in what you thought about the first time. You can't say, this is the way I thought it was going to be, and so that's what I'm going to do. If you get new information, you have to be willing to change your hypotheses.
Anytime you're faced with a problem that makes you think about the unknown,
Whether it's outer space or just something new to you,
it never hurts to take your best guess.
you may make a breakthrough. This program was supported in part by the National Science Foundation and was produced by John Allman and Art Fitzsimmons, under the supervision of the Agency for Instructional Technology, AIT.